Hi class, I'm making a video to explain the next project, and this is a paper written by Faulkner, and it's published in Journal of Finance in year 2006 by Faulkner and Wang. So this is a paper. It's very interesting, and the data is pretty easy to get. Is just CompuStat data. So it's very easy for us to replicate the data. But the person who write this code, he's my friend. He's working in a university in China, so he's using the Chinese CompuStat version, the Chinese version of CompuStat on the GTA 2008 data. We are familiar with this data because we're using this data set in the last project. He wrote the code and using the data of the Chinese version of CompuStat. But however, the methodology and also the results are very similar for the Chinese data and the US CompuStat data. Okay, so there's a PowerPoint posted. So this paper is studying the cash values, and also considering firms with financial constraints, and as compared with firms without financial constraints, the cash values are how much. So the hypothesis, there are three hypotheses. So the first one is the marginal value of cash is decreasing with the cash position of the firm. The second hypothesis is in a highly levered firms, the cash is less valuable to shareholders. And the third hypothesis is when cash is more valuable to financially constrained firms. So, this is for these hypotheses. The author is using this is their methodology. So the y-axis, the dependent variable, is excess return for each company in each year. So the first thing you should do is to figure out how much is the excess return. So RIT here, this is the returns of the firm. This one is the benchmark return. So use the actual return minus the benchmark return will be the excess return. So the benchmark return is using the standard way in finance, using 5 and 5 portfolio return, and then as a benchmark. So to see the company falls into which portfolio in this 5 and 5 portfolio, and then the difference between the average in that portfolio's return and the actual return of the firm, and that will be the excess return. This is the y-axis. And it's very interesting to see. It's quite confusing for the independent variables. So the major one is the first one. The major one is this is the delta of C is cash holding, and M is the market value. So the delta of cash holding is getting differentiation. The first derivatives of cash over time, over year here, or delta. The way it is calculated is just to get the difference between the prior years, assuming it's a normal cash holding, and the cash holding in the following year. So the difference will be the delta, will be the changes. So, and this is a major. If this is a major result, so if this coefficient is positive, it tells how much is the cash holdings value here. And also there's interactive terms. The CIT minus 1 is the cash holding in the previous year. So the E is the earning, I think. NA is net of asset, and you can find the definitions in the code here. So anyhow, so the data is just using CompuStat, but like I just explained, this paper is based on the Chinese version of CompuStat. So okay, let's look at the code. Okay, so let's start. I've posted the code into the website. This is the most recent one and it's working fine. Anyhow, so the first thing to do after you open this this Chinese version of the CompuStat data, and you don't need anything else, only need this financial database data. And then so you need to define the variables. So the TS set is just to make the data set a time series data. And then so the I here is using this one from this database. So this is financial cost or interest. The paper is using interest, so we can find this variable and use it for interest. And what's interesting is here, DI over L, this is market value, and L means it's a lag of the market value, and DI is the changes of interest. So DI means here delta of changes, or the differentiation, or the first derivative of interest over time, over year. That's DI, or delta of interest here. So because the model is based on, you see, all the models are based on the delta, the differentiation of the major variables. So this is I here, interest, this one. So the same thing, and the next one is just to get the dividend. Okay, and it's continued that way. And then dividend, and also DC is cash, and LC here is a lag of cash. DC is the delta of cash. LC is the lag of cash. DNA is the delta of net asset. Net asset definition is asset minus cash, and total asset minus cash, that's net asset. L is the total debt liability. E is equity. DE here is the delta of equity. So D dot E, this one will get the differentiation of the equity. No, this is E is the earning. E is the earning here. Anyhow, so here are all the definitions for all the variables needed. And then next thing, we will continue working on the data. And I will make further explanations in the next video. Thank you for watching.